We are live. Okay, good evening, everybody. We have a lot to talk about since we last were together, which was right before the little vacation time with the anniversary and Halloween. I hope everyone had an excellent Halloween. We had a discussion about the winter forecast, right? And we were talking about what to expect and how to expect it. And let me just move the camera here just a little bit. There we go. And we've had a lot of discussion of what we're going to be watching for through the rest of this month in terms of the winter forecast and what has happened since we last talked. And what has happened is some very interesting data. Very interesting indeed. So before I start, just want to welcome everybody for joining once again. It looks like we are very busy here on YouTube and Facebook. We got let me make sure I got the chat working correctly. And let's see here. Yeah, that looks good. It's always important to make sure that everything's working properly before we begin, because if we don't, then we end up with a lot of nonsense. So everything looks good. Okay, so let's look at some of the observations. We start off with for tonight, because tonight's a very important night, because tonight is the first freeze for everybody. And I want to explain what's happening here. So right now, this is the polar jet stream here and the subtropical jet stream. We're about 250 millibars. And you have this deep trough here, and this trough axis is starting to exit off the coast. Now remember, this shortwave is a positively tilted trough. So what that means is that the storm that developed, it was far enough out to sea where we didn't get the heavy precipitation, but we did get an inverted trough that produced steady precipitation. And I say precipitation because we had observations of not just rain, but also snow. We had the first observations in northwest New Jersey, the Hudson River Valley, the Poconos, Catskills, portions of Connecticut of our first dusting of snowfall. So we had our polar air mass actually invade. And with this trough starting to exit the region, we are seeing at the same time a ridge building at 850 millibars. So, and we have continuous cold air transport. You see how, let me zoom in on this here. See how the winds are perpendicular to the isotherms here? This is a sign of cold air transport. So when you see this sign, that means colder air is coming into the region. So we have cold air coming into the region. And when we take a look at our observations, our dew points are below freezing. So we have winds becoming lighter. We have skies starting to clear. This trough is starting to give way. This precipitation is basically becoming virga. And we're starting to see, let me pull up the visible here. Obviously, at night, you're not able to use a visible to full spectrum. So what we use is a geocolor mix. And what this shows me is that we have a lot of skies that are starting to clear. So we have clearing skies. We have dry air starting to build in. We have this trough exiting. We have winds weakening and dew points below freezing. So the combination of all these factors leads to temperatures plummeting below freezing, even on the coast. So if you have any plants outdoors, I hope you already brought them in. We have freeze warnings out already for much of the region. So it's going to get pretty chilly. Even out here towards Long Island, dew points are below freezing for most of Long Island here. And for much of the Jersey Shore, they're in the 20s. So yeah, we're definitely set up for a nice freeze here taking shape. So with this setup here, you have your first true polar air mass. And it's an important signal, because what it tells me is that the polar air masses are being supported to remain strong, to remain pure, and not be modified. Why is that important? Well, it's a signal that the snowpack idea in Canada of that rapid expansion is starting to play out. So first clue here for moving forward. And the good news over the next couple of days, we are going to moderate. We're going to warm back up into the 50s and 60s. It's going to be quiet. We have 2 weekends in a row of dry conditions. So we're kind of making up for all the rainfall that we saw in September and through mid-October. So that's certainly some great news. But what about the signals for the rest of winter? Well, let's go over it. First of all, we'll talk about the snow pack over much of North America. When we were talking roughly 10 days ago, we had a lot of below normal anomalies. And I said this needs to change significantly, because if we continue to have these below normal anomalies, that means that when polar air masses and Arctic air masses come across North America, they will moderate rapidly. And also, this could be a sign that the polar vortex remains stronger and doesn't get disrupted. So that's where we were 10 days ago, okay? Now we fast forward, and a lot of that below normal anomaly is wiped out. In Siberia, it's wiped out. Now, this is not the most impressive snow coverage that we've seen, okay? It's not well above normal or anything of that nature. If anything, it's right around normal, maybe slightly above normal. But the fact that it grew so fast is a really important signal. It means that the atmosphere is starting to shift and starting to react to what we're seeing with the other forcing mechanisms out there, like the EP flux and the influence of El Nino with the convection around the dateline, which we'll get to in a moment. But what it shows us is the potential for that expansion and for that growth. And so when I'm seeing this, and then I see this is the, from Earth News School, 850 millibar temperatures over the northern hemisphere. And what I'm noticing now that we didn't have 10 days ago is that not only are the polar air masses more expansive and the Arctic air mass is more expansive, but they're also deeper and stronger. They're more dense than what we saw. Now, you would expect that to start to happen as you move through October and into November as we head towards the winter months. But this was an rapid growth compared to where we were just 10 days ago. So this is a really important signal here that we're establishing our base here in Canada, that we're establishing our base here in Siberia. And so this tells me that, hey, we're going to have a robust polar and Arctic air mass to work with. The concerns I had when I wrote the winter forecast are being addressed. A bit of warning, though. Can this change? In theory, if we ended up with, let's say, an upper level low that just kind of parked here in the Gulf of Alaska, and just drove a Pacific air mass across Canada and warmed everything up, that would short circuit this whole process. Right now, I don't see any support for that happening, but I just want to throw that out there as something that could happen. So we have that process evolving, and then we see what's going on with the EP flux. Now, this is the observations as of 11/1. Basically, this is from last night. And you can see some of that transport starting to take shape here. 5 days out, it's a little bit stronger. Then we get a little bit of relaxation here. You see, when you have this direction here towards the equator, this is a sign that the polar vortex is going to strengthen and consolidate, which you would expect after a lot of disruption over the past 2 weeks. 10 days out, strong polar vortex is likely in this signal. 15 days out, again, something that I wouldn't take 100%, but what we could do is take this as a theme that might be evolving here. And that theme is that we start to see a return of that transport from the mid-latitudes of the troposphere to the higher latitudes of the stratosphere. This is a potential signal of a stretching or at least disruption of the polar vortex in some form by around, let's see here, by around the middle of November, which would signal, if you do a time lapse here, probably about the end of November, we'd see the actual impact of this starting to take shape here, if this verifies. Okay. So this is a very, very interesting signal and something that should be watched for the end of the month. And I know I'm already seeing the questions about Thanksgiving, but we'll talk about that in a moment. So while this is all happening in the realm of an east-based QBO. Now, this is why this is really important. A lot of El Niños feature a QBO that's westerly. And so you don't see a very strong support for a disruption of the polar vortex. But when the QBO is easterly and you have an El Nino, the combination of these two tends to support a lot of disruption of the polar vortex, a lot of stretching, and at times even splitting. It's not 100%, nothing in meteorology ever is, but it's a very, very strong signal. It's let's just put it, there's a better chance of there being disruption than not because of this signal. So what this tells me is that the atmosphere is primed to build up mass in the higher latitudes, in the stratosphere and troposphere, and increase the potential for high latitude blocking. That high latitude blocking can feed back on itself. Sometimes the high latitude blocking develops first, and then that works to disrupt the polar vortex. And then sometimes the polar vortex gets disrupted from the EP flux, and that leads to the development of high latitude blocking, which feeds back on itself and then disrupts the polar vortex again. So the process is never A equals B. There's always a lot of coefficients and a lot of unknowns. Okay, a lot of chaos. So you have to be prepared for that. But if what we're going to do, what we're trying to do tonight, and what we did with the winter forecast, is to give ourselves a guideline, an area of focus that we can have in terms of expectations. So if the QBO was westerly, I would say to you, hey, QBO is westerly, harder to create a disruption in the polar vortex. If the polar vortex gets strong in November, it's really hard to disrupt that, and we would move towards a mild winter. But because the QBO is easterly, this opens up an entire different gambit and explains why we are seeing more and more disruption from the EP flux. It all connects. It all goes with it. And that's why we've seen this evolution take shape. And that's why now that we've seen the snow growth, we can't move away from that. And now we can focus on what's happening in the stratosphere. And what I have here, this chart is from the cpc.ncep.noaa.gov. Okay, you can find it pretty easily. This is at 10 millibar temperature anomalies. And so what we watch here is the potential, and you can see it here, a lot of warmth showing up in the higher latitudes of the stratosphere. Now we need to be careful not to jump the gun on this. But unlike last year, where we had a very difficult time of getting warmth to grow and become sustained, this year already, because of the nature that we are in, we're already seeing that growth very nicely, very robustly. Now, what we want to see is for this whole column to warm. That usually doesn't get sustained, and typically we don't see that until later November and most of the times in January. But we're already seeing it now. So let's just say it's a very positive, very favorable observation. Again, this is not model guidance. This isn't, well, maybe in 15 days, or, well, maybe we might see it if the GFS and the European ensemble guidance pans out. This is the actual observations now. I always start off with the observations and not the models 10, 15 days out, maybe Wishbone will pray really hard and we'll post a bunch of snow maps out 15 days to get some hits. This is some actual observations of what is happening in the atmosphere right now. So if I'm looking at this, I'm pretty happy with where I'm at with my winter forecast based on what I'm seeing here. The observations are all moving in the right direction. I'm not seeing anything that says, hey, the polar vortex is going to strengthen and then it's going to remain strong. No, I see a lot of signals for a lot of potential disruption. So as we move forward over the next 10 days, and really when it comes to the polar vortex forecast, I trust what I see 5 days out. I find interesting 7 days out. And then, yeah, it looks nice 10 days out. We'll see what happens. Okay, I don't like going beyond 10 days because there's way too much noise involved to really trust it. But 5 days out or 120 hours out, what do we see? We see a disrupted polar vortex that starts to consolidate. This matches up very nicely with the GFS solution of the EP flux shifting more towards the equator, which would support a strengthening polar vortex and consolidation. The consolidation leads to a relaxation of the polar jet stream, which leads to moderation of the air masses over the mid-latitudes and a shift to a more tranquil weather pattern by the time we get to the middle of November. So this forecast 5 days out of the polar vortex makes a lot of sense based on all the observations we're seeing now. Then we get to 7 days out and we see the polar vortex strengthening. Again, this makes total sense. This makes a lot of sense based on what we're seeing. But notice that we are seeing a lot of focus more towards North America than we are towards Asia, even while the polar vortex is strengthening. This is a very important signal to me. In winters where you had everything come together and then because the polar vortex shifted towards China, everything got shifted towards Asia as far as storm potential. In the fall, we saw the polar vortex more frequently heading towards Asia. This fall so far, in the observations, again, we've seen the polar vortex focus more towards North America, which is a very interesting signal. Again, this can change, but it's a signal that has been sticking around quite a bit and something that I've been noticing quite a bit. And when I went back to my notes on previous winters, as I ranted about the fact that, hey, this winter forecast busted, we're not getting any snow, and everyone's going to kill me back in 2019, I noticed that the polar vortex kept on heading towards Asia. And I noticed that the transport wasn't as strong. And the QBO was, well, westerly. So now we're seeing that disruption. And now we're seeing this hint of this evolution taking shape. Now, again, this is where we go out to 10 days out. And now this is where we start to get a lot of noise. You still have the polar vortex shifting more towards Eastern Asia and the Aleutians. You're getting a lot of stretching towards North America. You're getting a lot of stretching already taking shape. Again, 7 days out, consolidated. 10 days out, you're starting to get this triple point stretching. 1, 2, 3. Which would suggest heights starting to build over Western North America again. So a lot of interesting signals showing up here. That tells me that the forecast we have in place is going in the right direction. Meanwhile, in the tropics, not much change. We have our El Nino rocking and rolling. The Atlantic remains very, very warm, which has led to an above normal hurricane season, much to my surprise. Look, my forecast was average to below average, mostly because of the strong shear. The shear was there, but it was displaced, as we discussed last time. But this warm water is really impressive. This is beyond a positive AMO. And this is going to be a very important signal for us. It's a very important signal because if you have all this warm water and it clashes with an Arctic air mass along the East Coast and around the Gulf of Mexico, that's basically nitroglycerin, man. That is a powder keg ready to go up. And this is a signal that we could be supportive of some very dynamic coastal storms as we move through the rest of fall and into winter. And this concern is not just about, hey, we could get a lot of snow. This is a concern that if you're on the coast, this means that we could be seeing a lot of coastal flooding events and a lot of beach erosion. So if you're on the coast, I would strongly suggest that you prepare accordingly, you have your supplies, and you have your plans if you need to evacuate from the shore. I'm not saying you have to do it now or anything like that, but what I'm saying is I have a plan and be prepared, because this is a very important signal that I'm seeing out here. Meanwhile, out in the Pacific, we're starting to see a shift of our El Nino from east base to central base. It's basin wide right now, really. All of our convection continues to be focused around the date line. In fact, when we take a look at the MJO forecast from a variety of models, notice a lot of the guidance is staying in the zones of 7, 8, and 1. Why is that very important? 7, 8, and 1 essentially is where you have all your convection around the date line. And you see this continuation of this focus around those regions and repeating itself constantly. So as we head through the late fall into winter months, this opens up your potential for more cyclogenesis on the East Coast, an amplified polar jet stream, amplified subtropical jet stream, all interacting with our polar and Arctic air masses. Finally, I just want to show, kind of follow back up on the SOI. The SOI does not show anywhere near a strong El Nino. Now, again, let me explain the SOI for you. The SOI is a good way to measure how El Nino is interacting with the atmosphere. See, like, you can look at the sea surface temperatures all you want, which is great, usually a great indicator. But, and I say this with a lot of caution, if the atmosphere isn't reacting to those sea surface temperatures, then you can't make an assumption that you're going to have a strong El Nino effect. So yes, sea surface temperatures around Nino 3.4 is around 1.5, 1.6, which is about moderate. Towards the eastern zones, around 2, 2.5. So the eastern zone's definitely strong. Central zone, moderate. The result of that from the SOI, which is our forcing signal, says, weak to moderate. And we're seeing some positive signals here, and from the daily contributions. But what stands out to me is the monthly and the seasonal, 30-day, 90-day averages. With a strong El Nino, I want to make this very clear, with a strong El Nino, I'm usually looking for over minus 15. Not seeing that at all. We haven't seen that at all for weeks. This is all of October. So the signal we're seeing, more weak to moderate as far as driving influence. And the convection is clearly focused around the date line, but the next thing we're going to be watching for is these daily contributions, because when you have positive contributions, that means that most likely you're going to end up with a quiet pattern on the East Coast. When we start to get sustained negative contributions, we end up with an active pattern on the East Coast. So this is kind of like our signal, right? Red light, green light. Red light is the positive anomalies. Green light is the negative anomalies. So you could see when we had our last stormy period, a little bit quieter now, and then we move into our next stormy period for early November. Not too stormy, not too bad. And then mid-November, we get more of a Pacific air mass dominating. So a lot of interesting signals all playing together. And so what that leads to is our 500 millibar pattern remaining pretty interesting and active through the first part of November. And then you can see the upper level trough shifting towards the Gulf of Alaska, and that allows for your Pacific air mass to dominate and push through much of the United States, which is shown on the European GFS, European ensembles, GFS ensembles, Canadian, so on and so forth. Pretty strong agreement on that. That's going to lead to a mild period for the middle of November, but you could already see the signals showing up here towards the end of this forecast period on the ensembles, on the European guidance. Pretty strong signal of a trough around the Aleutians. Nice signal of a ridge, probably a flat ridge here, over Canada. And then a broad trough, possibly a negative NAO signal. We'll see if this comes wrapping around. I did see some of the later mild guidance beyond this point. There is some signal for the end of November, which I mentioned in my discussions for premium members when we talked about the entire month. End of the month is very interesting. But I think that's all we can really say at this point. To be fair and to be responsible, that's as far as really anyone should really go in that respect. So over the next 90 hours, our trough leaves, our pattern becomes a little bit more zonal, the troughs moving through are going to be weaker, going to be a pretty quiet period of weather with, after a very chilly start tomorrow morning, we'll see moderation in our polar air mass to more of a modified Pacific polar air mass. And that's going to lead to quiet conditions for this weekend, once again. Definitely get out there and enjoy it. And then we're going to watch one low pressure system here. I still would be concerned that this could be jumping towards the Gulf of Maine, and keep an eye out towards like eastern Long Island and Connecticut if that happens. Right now this passes to the north of us with scattered showers, but we'll keep an eye on that. And then our next low pressure system that comes through around the 10th. Again, this is another signal where we could see a redevelopment more towards the eastern Long Island and the Gulf of Maine. But certainly a nice little snow potential for the Green and White Mountains here that we'll keep an eye on. For all you snow lovers out there, I'm going to give you a little tip. You do not want snow in November. There are very few impressive winters that I've experienced where it snowed heavy or snowed significantly in November. I'm not talking about a flurry or something of that nature. That's not what I'm talking about. I mean a real snowfall. A lot of people will push like, hey, can we get real snow in November? Honestly, from my experience, you really don't want it, because what that tells us is that the pattern that supported that snowfall in November translates to a milder pattern in December and January. So you really don't want to see that take shape. So we'll keep an eye on it once again, but certainly an interesting pattern nonetheless. So with that, I am going to take all your questions, and let's see, we have some activity here on YouTube as well, and we'll go from there. Let's see here. Rob starts, man, you have got to be excited as winter weather fans with OBS and what the models have been hinting over the past 72 hours. Low level cold air fighting today. West base negative NAO block. That's important, by the way. The NAO block, position of the NAO block. Let me just put myself up here. Okay, good. The position of the NAO block is going to be a big deal this winter. Okay. If we see the NAO block shift more towards east base, towards Iceland, and the ridge, let's say, only gets to central Greenland, that opens up the potential for storms either to slide to our south or to lift up towards the eastern Great Lakes and then redevelop towards the Gulf of Maine. So that's really important. For you winter weather lovers out there, you want to see a west-based negative NAO, because that increases the potential for a storm track over our coastal waters and keeps cold air locked into the coastal plain. So that is something that we definitely have to watch. EP Flux, I wouldn't say it's bananas just yet. It's certainly in the right direction. I'll tell you that. And as far as Thanksgiving week, I really don't want to jump the gun on that yet. I really, really don't. When it comes to this type of pattern, when you're talking about polar and subtropical jet streams, you're talking about the interaction of short waves. And timing is really, really important. So this winter, really the rest of fall and into winter, you're going to be dealing with a lot of phantom storms. A lot of storms that will show up on the GFS and the European 7 to 10 days out, 15 days out is a given, but then they'll disappear. Why do they disappear? Well, the reason why is because as the models gain more observations and as they start to bring in more data and better understanding of the short waves within these individual jet streams, they start to understand what the orientation of each shortwave is, the speed, and the strength. And as they get a better idea of each one of those factors, it changes the forecast or it trends. So what you're really seeing with the model trend is the models gaining more and more data, more and more observations that have a better understanding of what is going on with that short wave. So if a short wave originally 10 days out is forecasted to be in a neutral to negative tilt, that leads to a far different solution than when you get to 5 days out and in reality the trough is neutral to maybe slightly positive. So as a result, the whole lifting parameters are all more progressive and shifted to the east, and so instead of a big storm, you just get a cold front. So you could see why I'd be very hesitant in this type of pattern. More so than in La Nina. In El Nino, because you have short waves coming in not only from the Arctic, which is very hard to sample, but also the tropical Pacific, which is hard to sample, you get a lot of false storm signals 10 to 15 days out. So I'm warning you, there's going to be a lot of false signals out there, so just don't get too wrapped up into it. Card, good evening, Card. I know that there has been research about Siberian snow growth and the impact on the polar vortex. Yes, and definitely check out Dr. Judah Cohen on X. And he has his own website, which you can find when you follow him. Outstanding atmospheric scientist that I strongly suggest you follow. Does an amazing job with this research. Let's see here. And the impact on the polar vortex, but anything comparable has been done for Scandinavia and Western Russia. As far as I know that there's some preliminary research on it, but nothing that has been out as far as peer-reviewed yet. I believe they're still working on it. But what I will say is not so much the snow growth, but the development of the height field around Scandinavia is very important in the potential for disruption of the polar vortex. If you start to see above normal heights building into Scandinavia, then what you're going to start to see is a greater impact on the polar vortex at the 100 to 50 millibar level. And you're going to start to see at first a stretching, and then you're going to start to see heights come across, almost like a bridge across the Arctic. And that is a signal that allows for that split in the polar vortex. Let's see here. Snow growth influences. Okay. Hope it gets cold enough tonight to kill the spotted lanternflies. Killed over 20 of them on a maple tree the last 2 days. Yeah, I believe it. Any preliminary thoughts for Friday to Sunday right after Thanksgiving? Way too far out. Way too far out, guys. Look, I really don't want to go out that far. And I'm going to tell you why. because the model guidance that far out is noise. That's it. It's noise. Now, I get it. A lot of people are traveling. They want to know as soon as possible. What I will say is this. The end of November is more likely to be more active. What that means as far as actual storm development or what to expect, I have no idea. Neither does anybody else or even those models that go out all the way out to that time period on your app. Because there's just way too much noise and way too much volatility going on out there. That's why I would never issue a forecast right now in that time period as far as any details. I'm not going to do it. Can't do it. I mean, I might as well just make stuff up. I could just get myself a magic 8-ball and shake it up. Because it's not in our capabilities. Now, the next live chat next week might have a little bit better idea. Of course, I will be issuing, as we get closer to Thanksgiving, a forecast, obviously, for travel, just so that people are well prepared. And, if you have questions, definitely ask them if you're a premium member. I'm not saying don't. I'm just being honest with you. We don't have the data to make a forecast that is reliable. I'll put it that way. But definitely a higher potential of being more active. That's as far as I could possibly go at this point. Let's take a look at YouTube and see what we got here. Wow, we are pretty busy here. Ready to see your opinion on weather from... Well, thank you, Dylan. What websites do you use for weather forecasts? Oh, wide variety. I definitely use NOAA websites. SPC, great. Let's see here. Earth.newschool is great for observations. Aviationweather.gov, which is another government website. Absolutely great observations. I've been using WeatherTap for radar, which is paid for since 1998. I think I might have been one of their first few subscribers back in the day. Of course, a lot of NOAA data. And then as far as models, you can go with free websites. I like to use weathermodels.com. It's a paid website, but very much worth it. But there's a lot of great. You could go to NOAA. You could go to ncep.noaa.gov, and you could check out the free models there as well. That's some great options for you as well. Thanks for the live stream. I'm 26. Been following you for 14 years. Wow, holy smokes! Learned a lot. I feel old. Oh my God. Wow. Okay. Well, I'm not old, but that's a long time. You don't really, and it doesn't feel like 14 years. You know what I mean?
What, for us?
Yeah.
I know.
It's weird. It's like,
I know.
I don't know. But learned a lot from you as a kid who loves snow in the Northeast. Thank you. Well, thank you for following. You got some put in the Northeast in October, and winter was a blowtorch. When you study weather models, do you use AI? No. AI is going to be fun. It is going to be fun to challenge. Look, the way I see it is that I'm never going to stop learning. That's the one thing that got me into meteorology. Once I got over the whole snow thing, when I was 5, 6, 7, is that there is never going to be a day where I'm like, oh, I know everything. I'm done. I'm going to move on. I know everything I could possibly know. I experienced everything I could possibly experience. Never going to happen in meteorology. You're always going to be constantly challenged. You're always going to be constantly pushed. So I welcome AI. I mean, I think that it's going to be something that will force us to get better. The only thing that I'm worried about with this whole AI thing, and it's more for the younger meteorologists out there, is that there are going to be some businesses who think that they can replace AI with the meteorologist, right? That they could replace the meteorologist with the AI, should I say?
Yeah, I was gonna say.
Yeah, and the problem with AI is that it's only as good as the data it gets. And if you have bad data, how do you adjust for that? And how do you explain that to a human audience? There's some humans that have difficulty explaining that to a human audience. So I think AI is interesting. I think it's an interesting component, not only in atmospheric science, but in a variety of different factors going on in our lives. I don't know what's going to happen. I'm not that smart to make that type of prediction. And there are people who are way smarter than me in that field who don't even know the answer to that. Some are very cryptic and some are very hopeful. But I say, and this is part of one of the reasons why I developed my own platform, and I saw this is nothing new, by the way. I saw this starting to happen back in 2005. I was working for a company, I will not say which company it was, but they wanted to automate everything. What they essentially wanted to do is create an algorithm where they take all the model guidance and they average it together. And then your job was to go in and to remove all the 999s. Now, I left that job because, one, I didn't spend all that time in college to go and just do remove 999. I wanted to forecast, not be a data engineer, which is nothing wrong with a data engineer, but it's not something I'm really interested in. So they were starting to do that. And then what they would do is that they would cut down the workforce so that they can replace it with this average model and then only have, let's say, you don't have to know the whole region. You just had to remove the bad data. And then it failed. Why? Because the models that were going in needed to be adjusted. You couldn't just do raw model data. And so that's what you have in a lot of your apps. This is why your app will say, hey, it's going to be sunny in 38, and instead it's snowing in 32, right this moment. And the reason why is because that app is only getting the best data it could possibly get from the observations and the data that's fed into it. And there isn't any adjustments. So that's why you see what you see. So it'll be interesting to see what happens going forward. Do you feel like El Nino is having an impact? Oh, definitely. El Nino is definitely having an impact. I have no idea whether or not we'll see blizzards in December or January. Your better potential is mid-January to early March in El Ninos. And I'm not me, as you know, and I will say this again, for the northern mid-Atlantic, there is a better chance that there's only a 10% chance, if everything goes right, for a white Christmas in the northern mid-Atlantic. More like 1% the closer you get to the coast. So I wouldn't bank on any type of snow event for late December. But I'm not ruling it out. I'm just saying it's very, very difficult to pull off. Let's see here. AI tends to make things up. Well, make things up. Let's see here. It kind of depends on the data it gets, right? So, all right, if you feed AI a bunch of nonsense, it's going to spit out nonsense. This is true with any model. This is also true with the GFS and the European, which is why we have model errors, by the way. If you feed in that, hey, New Jersey is 97 degrees right now into the model doesn't have eyes and take a look and says, no, it's 32 degrees out. What are you talking about? It's just going to take the 97 degrees and work that through the model guidance. So, as I said, the model guidance or the AI is only as good as the data it gets, which is why if I was running things with NOAA, I wouldn't focus so much on the model data, the models themselves, although the physics equations at GFS could use some work. What I would do is make a big push to increase the amount of data networks, the data collection throughout the United States. Create mesonets throughout the United States. Because if you collect more data and then you build models around that deep that dense data collection, then you significantly improve the resolution in your models and the potential of being able to forecast for mesoscale and synoptic events far better than what we have now. We have too many areas where we have basically no data or limited data, and that really hurts us when we're forecasting. So I think if I was running things with NOAA, that's what I would focus on, creating more densely packed areas of observations, both with upper level soundings and also with surface observations. And then feeding that in, I guarantee you, if you feed that into the GFS and the European, you're going to get much better forecasts 5 days out. So that's what I would do. That's how I would go about that process. So we have definitely had some great questions tonight. Wow, it's already 8:46. Wow, that went fast. What do you know? So I'm going to take a couple more questions. I think we pretty much covered a lot of stuff here with the pattern overall. As far as I can tell, as far as what I'm seeing, I'm really happy with what I'm seeing with the evolution of this pattern here. There's nothing here that stands out that says, uh-oh, this might not go well, or I might have to go make adjustments. If anything, we've trended to a colder solution possible because of what we're seeing with the snow growth. We'll have to continue to watch that through November to see if that continues to evolve. But everything I'm looking at is telling me, hey, this could be a very interesting year. I know that a lot of you snowplow guys would love to hear that. That is for sure. I certainly hear that a lot from a lot of guys like, hey, we really, really need a really good year for business-wise. If I could control the weather, I would definitely give that to you. There is no doubt about that. But I would have to like what I'm hearing. Yeah. See, on that point, has forecasting, let's use winter storms as an example, become easier or have stagnated or stalemated since 2008, 2009 when I became winter weather weenie? Seems similar to me since back then. I think one of the problems that we have in forecasting, let me go back here. Okay, so I think that the data is better, but I think there's sometimes too much data. And I think what happens is that we try to pull so many different models that we try to merge them together and we get data paralysis. What data paralysis basically is that you're looking at so many different models, you haven't developed a game plan. All you're doing is jumping to whatever model is being put out. So you have a game plan with your forecast and you say, okay, this is what I'm expecting. Here are the boundaries that I'm expecting, and this is what could happen in worst case scenario. This is a least case scenario, okay? Then you have the NAM come out and it drops a 35-inch blob of snow over I-95 corridor and everyone freaks out. So you get a lot of adjustments. And I think part of this is that with the weather apps, they try to produce a very specific finite forecast that really cannot be supported by our abilities. And so people expect perfect accuracy. and we're not there. We haven't been there. We never have been there. I think that the way that we explain these forecasts has to improve. But if I'm going to be honest with the general public, I'm talking about you guys. You guys are great. But the general public, sometimes, I don't know, like for example, the heavy rain event that we had in the fall, where somehow people didn't know that it was going to rain, even though literally we had flash flood warnings out. We were talking about for a week. Everyone knew about it that was in our circle. But somehow, again, I can't go and knock on someone's door and scream, hey, it's going to rain a lot. Be prepared. So I think that's a problem where people aren't paying attention sometimes. And I think that needs to be addressed as well. But I think that the science is progressing nicely. I just think that sometimes you got a lot of too much data and it creates data paralysis and a lot of confusion as a result. NAMD. Exactly. I'm still worried for coastal plains, low elevation coastal plains, low elevations like Lakewood. Wind even slightly to the east destroys everything. I mean, it kind of depends on the storm. There's a lot of factors that depend on that. I mean, there's the nature of the air mass that you have in place, the evolution of the storm. Lakewood, in general, is an area that is, well, I mean, it's southeast New Jersey, essentially. So you're not in the best spot. It's not like you're in central or northwest New Jersey where you're protected by that. Let's see here. And so, you know, what I would say, anyone that's on the immediate coast, this is like Lakewood, Belmar, all that stuff, even in a situation where you have mostly snow, your areas are going to be most likely to get that snow, sleet, rain mix. Just because that's the nature of your climatology, you know? That's a trade-off with being on the coast and being able to get to the beach real fast, is that you're going to be dealing with a lot of wintry mixed slop in your location because of the very nature of the boundary layers around your location. In order to get a pure snow event in Lakewood, I mean like all snow, heavy snow, so on and so forth, what you need is a northerly wind, a polar air mass with temperatures between 28 and 30, and your 850 millibar temperatures over you around minus 6 degrees Celsius or colder. That's really hard to pull off. So, but that's what you would need. So, unfortunately, not in the best place. You know, I think that they're working on some improvements with the NAM or replacing the NAM. So we'll see what happens. The NAM isn't a bad model if you use it appropriately. So the NAM, like the HRR, is a convective model. So what some people try to do is use the NAM as a model to solve synoptic problems when you should really use it only for mesoscale problems. So it's the wrong tool for the job. So what I use the NAM for is, and when I'm looking at it, I don't necessarily care about the QPF output. What I'm looking for is like, hey, is the model giving me signals for convective precipitation within the storm? And so if it is, then I can pinpoint, hey, central New Jersey, for example, is exhibiting on the NAM a lot of support for convective snowfall. So we have to look out for mesoscale banding. That doesn't mean I take the NAM now and take the 36 inches and put that in the forecast. What I do instead is say, okay, here's the going forecast. And the same thing with the HRR, by the way, and all these other mesoscale models. Here's the going forecast. Heads up, if we get these mesoscale bands setting up, they can produce additional snowfall above the base that we have in place. And this could lead to areas where you could get, instead of 6 to 12 inches, you could get pushed up to the 18-inch mark because of snowfall rates of 2 to 3 inches per hour in these snow bands. And much like trying to forecast a thunderstorm, you don't know exactly where it's going to occur, but at the very least, the public is aware that the potential's there and can prepare accordingly. So let's see here. Non-weather related, just saw the college basketball coaching legend Bob Knight passed away. Oh my God.
Yeah.
83. Wow. That guy was something. That guy had a temper sometimes, but wow. His players loved playing for him. Well, with that, I think I'm going to call it a night. I think we covered a lot of great questions. As always, you guys were outstanding. Again, thank you as always. And look, tell your friends and family that, hey, look, this is a great... yep.
Tip on YouTube.
Oh, look at that. Oh, thank you, Izzy. Very nice. Awesome. I never got that's really cool. Thank you very much. I'm going to wrap it up for tonight. And with that,
Hope everybody had a great Halloween.
yes, I hope everyone had a great Halloween. And, we'll be following along with the pattern, as I know I'm going to get more and more questions about Thanksgiving. If you want to help the channel, again, let your friends and family know where you're getting this great weather information so they can follow along and check out the feed and ask questions like you just did. And also, if you're interested in helping the companies, for some of you guys out there on YouTube, definitely check out the Premium Consultant membership because, hey, for the season, it's going to be well worth it, especially if we're going to be following these winter storms. That is it for tonight. Have a wonderful night, and as always, stay safe out there.